Okay, hello everyone. We are now on module 4, which is soil compaction. However, before we discuss certain concepts on soil compaction, let us try to identify the learning outcomes for this chapter. So at the end of this module, the students are expected to define compaction, determine standard Proctor tests, obtain the maximum dry unit weight, discuss how the factors affect the degree of compaction achieved by a soil, discuss the modified Proctor test and why it represents field condition better than the standard test, determine some correlations involving compaction, discuss the structure of compacted clay soil, illustrate how compaction affects cohesive soil properties, determine the compaction in a field, discuss the specification for field compaction, and the ways that contractors try to meet them economically. So basically, the next one is explain the sand cone, rubber balloon, and nuclear methods of determining unit weight of compaction, discuss the compaction of organic materials, discuss some soils that have better compaction characteristics than others, and explain some special methods of compaction. So basically, our concept, our module deals with soil compaction. So when you talk about soil compaction class, compaction is being defined as the densification of the soil to make it more compact, to make it more compact so that the main purpose is to increase its soil density or unit weight accompanied by the decrease in air volume. So basically, we talk about compaction of the soil. When you compact the soil, there is of course, our soil contains air, so we try to compact that one, and it generally decreases its compressibility and decreases its permeability, and it will reduce the voids ratio, making it more difficult for water to flow through soil. So why is it important to us, since we are civil engineers, why is it important that we have to compact the soil before the construction of any structure? Basically, proper soil compaction is essential for any type of construction project. Why? Because it is a process in which the soil, which has consisted of air and water particles, is reduced to some extent by applying weight. So basically, of course, we know, we have discussed before, the soil itself has the natural state of the soil. It was divided into three parts. Of course, you have the air, the water, and of course, the soil itself. So basically, we want we wanted to reduce the voids within the soil, because that voids is basically being filled up with air or water. So the process of compaction involves removing air from the soil particles without any significant change in the amount of water consistent in the soil. So it is important because it provides the necessary flat base, which provides the crucial support for the buildings, various construction foundation, roads, pavements, and any other construction structures. So the process of compaction gives the soil higher resistance and greater stability. So usually soil is divided into two main categories, and we know that it is cohesive and non-cohesive soil. So therefore, the process of compaction is different depending on the type of soil. So basically, before the construction of any structure, it is necessary for an engineer to consider compaction, because through the process of compaction, it will guarantee that the soil bearing capacity of the soil will be more stable compared to a certain soil that was not densified. Because once you densify the soil is being compacted, and it will increase its strength, which is necessary for a certain soil to hold the capacity of any structure that will be constructed in that particular area. So it is important that compaction should be first consideration before building up any structure on that particular area, on that particular site, so that the stability of the foundation as well as the superstructure would be guaranteed. So basically, that's the main purpose of compaction. So for compaction, there are, of course, we have laboratory compaction and we have field compaction. So compaction, of course, as mentioned for our general principles, it is the densification of soil by removal of air, which requires mechanical energy. The degree of compaction of soil is measured in terms of its dry unit weight. So when water is added to the soil during compaction, it acts as a softening agent on the soil particles. The soil particles slip over each other and move into a densely packed position. The dry unit weight after compaction first increases as the moisture content increases. So we have to take note that at the moisture content is equal to 0, the moist unit weight, gamma, is equal to the dry unit weight. So we have here this expression for the unit weight wherein it is equal to the dry unit weight for as long as the moisture content is equal to 0. And when the moisture content is gradually increased if the same compactive effort is used for compaction, the unit weight or the weight of the soil solid in a unit volume gradually increases. So for example, the moisture content is equal to a certain moisture content 1, so we could have that the moist unit weight is equal to the unit weight after certain as the weight of the soil of the solid in a unit volume gradually increases. So for our compaction, we have the laboratory compaction, which is through the process of standard Proctor test. So when we talk about Proctor test, the soil is compacted in a mold that has a volume of 944 cubic centimeter, and the diameter of the mold is 101.6 mm. So during the laboratory test, the mold is attached to a base plate at the bottom and to an extension at the top. So this is, of course, during compaction, you're going to deliver 25 blows to each layer. So basically for the standard Proctor test, you're going to have layers. You have 3 layers for standard Proctor test. For every layer, you're going to compact the soil and you're going to deliver 25 blows. So after that, you're going to, of course, the hammer has a mass of 2.5 kilogram, and you're going to, after you have compacted the first layer, you add the second layer, then you compact again 25 blows. Then afterwards, the third layer and compact again 25 blows. So the hammer, as mentioned, is 2.5 grams and has a drop of 30.5 mm. So for that standard Proctor test, basically our objective is to get the maximum dry unit weight and the optimum moisture content. So that is the parameters that we are going to obtain as we conduct our standard Proctor test. Of course, we have a modified Proctor test. In the modified Proctor test, you're going to use the same mold as the standard Proctor test with a volume of still 944 cubic centimeter, and it has a mass of 4.54 kilogram, and which means that in modified Proctor test, the hammer is heavier compared to the hammer in the standard Proctor test, because in standard Proctor test it was only 2.5 kilogram. That's one is the modified Proctor test, you have 4.54 kilogram, and of course it has a drop of 457 mm, which is higher compared to the standard Proctor test. And still, the number of blows that you're going to release to deliver for each layer is 25 blows, same with the number of blows that is being released on the standard Proctor test. So that is for the modified Proctor test. So we're going to show a video on how the standard Proctor test is being conducted. And of course, if there is a laboratory compaction, there is a field compaction. So we're going to have a footage on how it is being done on the field compaction, which is being done before the construction of any structure. And of course, we have some special compaction techniques, which is basically being done to enhance the quality of the soil before constructing a certain structure.